Hello, I am Ivan Felix Seredilla from DCPET 21 from PUP ITech. Now our main topic for today's video is Mars Climate Orbiter Failure Mode releases report numerous NASA actions underway in this month. So, what is the report all about? The focus of the report is on the circumstances behind the failure of Mars Climate Orbiter mission. The primary reason for all the spacecraft loss is provided in the report. They also explain to us how NASA addressed the problems. And the mission of the spacecraft is the Mars Climate Orbiter or MCO and the Mars Polar Lander MPL. The MCO was launched on December 11, 1998, and the MPL was launched on January 3, 1999. So, what are the eight issues? What are the issues of the case? There are eight key issues of Mars Climate Orbiter spacecraft, and that is insufficient consideration of the mission as a whole, and inconsistent communicating and training with the project, and lack of complete verification of navigation software and computer models. Next is errors in ground-based computer models for aircraft cluster firing. Next is inadequate information provided to the navigation about the spacecraft orientation. Next is failure to perform a final engine firing to adjust the spacecraft path. The next is weaknesses in system engineering and adequate tracking of mission aspects. And next is informal communication channels among the project engineering group. In the first issue, which is the insufficient consideration of the mission as a whole, is they don't plan it carefully and they just give each other the request of their project. So they need to plan it as a whole and not just give parts of their projects on each different persons or teams. And inconsistent communication and training within the project. We need more we need to communicate more, especially on this project, because it's very crucial if we don't manage to communicate and share every details that might come back later as a big problem. In the third issue, which is the lack of complete verification of navigation software and computer models, they did not check the software and the models they used for the mission. This is also lead the spacecraft mission as a failure because again they did not check the software and the models they used for the mission. For the fourth key issues, which is the errors in ground-based computer models for spacecraft cluster firing, the model used by the computer is very critical for any spacecraft mission. So any errors in these models can lead to catastrophe that were shown on the report. For the fifth is inadequate information provided to navigation about spacecraft orientation. The navigation team can only work by the information provided, so if this information is lacking, there can be a severe implication. This is the main problem that leads to that leads to bigger things. So we must take consideration and attention to every single step on the process of the project. And second question is, what are the issues of the case? Ay, again. The third question is how NASA addresses the issues. So first, they mobilize the expertise at the Jet Propulsion Laboratory to address the report's recommendations. Second, they give a special attention given to the navigation and propulsion issues to an independent review. And third is communicating recommendations to the team planning and Mars Polar Landers landing and conducting fault-free analysis and teleconference for technical progress evaluations. And they increase the availability of the deep space network to improve spacecraft communications. As I said again, in the issues is they are lack of communication and they don't plan it as a whole. So that's why it leads them to a failure spacecraft project. And they appoint a senior management leader to improve and review the work plans. And they also conduct an independent peer review of operations contingency procedures. They make an effective progress to prevent critical mistakes in the future projects. So, how NASA addresses the issue at first is just like I said before, they mobilize the expertise at the Jet Propulsion Laboratory to address the report recommendation. So NASA read the report and they call the Jet Propulsion Laboratory and NASA act about the issue and they give a lot of recommendation on each every issues. And for the special attention given to the navigation and propulsion issues through an independent review, a lot of issues there failure is in the engine firing in the navigation. They give a special attention to these issues. It is necessary to have a good navigation model and solid propulsion testing. So in the third is communicating recommendation to the team planning and the Mars Polar Landers. So they made sure that this will not happen again and made sure to give some details about what they found on the team landing. In short, they need to give more details or communicate more, especially on the project like this, because they will lose a lot of money if they fail on these simple things that can lead to a bigger problems, just like I said before. For the fourth is conducting faulty analysis and teleconference for technical progress evaluation. So they lack of communication and plan. So they made a daily conference and check the progress daily. They also make the faulty analysis. And for the fifth is they increase the availability of deep space network to improve spacecraft communication. So if you if, so they give a lot of attention on this deep space network. So it allows us or them to communicate more efficient on space. So for the next address for the next NASA address the issues is they appoint a senior management leader to improve and review the work plans. They also conduct an independent peer-to-peer review of operational contingency procedures. They make effective processes to prevent critical mistakes of the future projects. And that's it. And for the fourth question is, how important the knowledge in the field of the computer engineering in the space technology? So, computer engineering in space technology is very important, and for the fact that mechanical engineers use computers more extensively than any other physical scientist. Computers are used to help in design process. Computers control manufacturing equipment and robots, and computers are used heavily in the fields of fluid mechanics and solid mechanics and heat transfer. So, the modern digital computer has been fundamental to the space exploration program. Computers have profoundly affected almost every aspect of space technology, including space design and celestial mechanics, missions control, and gathering the processing of the data generated by the spacecraft. The fifth question is, what is your takeaway as a future computer engineers based on this case? And for me is, we must be aware of the validation of every process for each step in the project. Also, we must take consideration of giving an attention to unit of conversion and consistency. Even small things can lead to a big problem. That's what I learned about the main project of the NASA spacecraft failure. Also, we must think about our future project as a whole and not rely only to electronics. And that's all. Thank you for listening.